Hello everyone, and thanks for watching Edupedia World videos. In this session of atomic structure, we'll continue with our analysis of electromagnetic waves and we'll go into the details of electromagnetic spectrum. Alright, so first let's start with electromagnetic waves and its analysis. We have already seen electromagnetic wave. Okay, we know about its wavelength, we know about its amplitude, its propagation velocity, its direction of propagation, and some terms like amplitude, wave number, etc. Okay, so now let's look at its velocity in detail. Okay, so if you remember, I told you that velocity of electromagnetic wave in vacuum is constant. Okay, and that constant value is always equal to 3 into 10 to the power 8 meter per second. Okay, so speed of light in vacuum is a constant. That's why we can have a separate alphabet assigned to it, small c. Alright, and this is not the exact value. The exact value is different. It is 2.9974, something like that. But you just have to remember the approximate value of velocity of speed or speed of light, which we commonly know it as, or it is the speed of any electromagnetic wave, which is equal to 3 into 10 to the power 8 meter per second. You have to remember this value. Okay, it's very important. Alright, and after this you have to remember a very important relation between speed of light, frequency and wavelength. That is, c is equal to nu into lambda. Okay, now once again, this is the velocity in vacuum. In material medium, if you try and make an electromagnetic wave travel in a material medium, you will have to introduce some correction factors for its velocity or speed, but we don't have to go into that. As long as you make that wave travel in vacuum, it will always have a velocity, a fixed velocity, which will always be equal to 3 into 10 to the power 8 meter per second, and hence the frequency and wavelength will always have fixed value for that particular electromagnetic wave. That is, the product of frequency and wavelength will always be a constant value. Okay, that is, in other terms, you can say that if I have to calculate frequency and I have the wavelength, I can always do that using this formula. Frequency is velocity by lambda, or lambda is velocity by frequency. Okay, that is, frequency is always inversely proportional to wavelength, or wavelength of any wave is inversely proportional to its frequency. That is, if you have a very long wave, that is a wave with very large value of wavelength, then obviously its frequency will be low, because frequency is the number of waves passing through a given point in 1 second. So if the length of wave, linear length, is very long, very high, the number of waves passing through the point, a single point, will obviously reduce. And if the length is smaller, then large number of waves can pass through the single point. So frequency has to be inversely proportional to wavelength. And you have to remember this mathematical formula. It is very, very essential. Okay, so now that we know about frequency and wavelength, we also know that if I know any one of this value, whether frequency or wavelength, I can completely define my wave. Okay, so this is the essential property or characteristic property of an electromagnetic wave. So if one wave has a wavelength of 400 nanometer and another wave has a wavelength of 100 nanometer, then those are two different electromagnetic waves. Alright, and once you have their wavelengths, you can calculate their frequency by simply dividing velocity of light, that is c, with c divided by the wavelength. Okay, so this frequency or wavelength can be used to discriminate or differentiate between different electromagnetic waves. Alright, and bunch of waves, okay, of different wavelengths taken together is what constitutes an spectrum. Alright, so what you do is you take a wave, alright, and you take its photographic representation. That is, you take, say, a linear representation of different waves. So this line represents one single wave, say, of 100 nanometer. Similarly, you take another wave and represent it over here, say 400 nanometer of wavelength, 400 nanometer, and so on. You keep on doing that. So wavelength can take any arbitrary value, which means all these lines represent individual waves of specific wavelength, and there can be infinite different kinds of wavelength between two specific wavelengths. For example, between 100 and 400 there are infinite number of different waves, because there are infinite number of digits which can be represented over here. So all this bunch of waves taken together is what constitutes spectrum. Okay, so spectrum is nothing but bunch of waves taken together. Alright, so how does electromagnetic spectrum looks? So let's look at a crude representation of electromagnetic wave spectrum. Okay, so this is a common representation of electromagnetic wave. Alright, that is, say this is the starting point, gamma rays. Alright, gamma rays are also a form of electromagnetic waves. Okay, so let's start from here and keep on increasing the wavelength. Okay, so this wavelength is a particular value, then this wavelength will have a particular value. Alright, this wave will have a particular wavelength, and so on. And if you keep on increasing the wavelength, you start entering the X-ray region. So after a certain value, alright, that is, there is no specific value, but after a certain region, you can say that you have left the gamma rays region, and the waves now which you are dealing with are X-rays. Okay, so in this region of wavelengths, if any particular electromagnetic wave has a wavelength of present in this region, then it can be said to be an example of X-ray. Okay, which have very high medical applications. Alright, gamma rays are what we see in discharge of atomic nucleus or nuclear decay. Alright, then if you still further keep on increasing the wavelength of wave, okay, you will start entering the region of ultraviolet ray or UV ray, something which we all have commonly heard about, sun rays. That sun rays constitute ultraviolet rays. Okay, there are other waves also, okay, present in the sunlight, but it gets filtered out. Alright, as it reaches earth and through its atmosphere and other obstacles, finally you deal with UV rays, and if you even further go on increasing the wavelength, you finally enter the visible region. Okay, visible region of your electromagnetic spectrum. Now this again is a very important region for us, because this is the region because of which we can see everything around us. Alright, only when the light ray has a wavelength between this region, okay, which is approximately between 400 nanometer and 700 nanometer. Okay, this is approximate values, not exact values, but between this region lies the visible part of your electromagnetic spectrum. So we can only see, of all the millions and billions of different electromagnetic waves, we can only see the waves which lie between this region, 400 to 700 nanometer. Below 400 nanometer we cannot, our human eye cannot perceive the waves, and above 700 nanometer also we cannot perceive the waves. For example, you cannot see UV rays with your naked eye. You can see its effect. You can see displacement of dust particles surrounding the electromagnetic wave or the UV wave. Alright, but you cannot see the ray itself. But visible ray is something that we can see. In fact, we are seeing right now as you are looking at this video. Okay, but now if you further go on increasing, alright, if you further go on increasing the wavelength, you will start entering the infrared region. Okay, this is the IR or infrared region of your electromagnetic wave. Now infrared region is, obviously all these regions can be further divided, like infrared is divided into near infrared, shortwave infrared, middle infrared, and even thermal infrared. Okay, so infrared wave, for your purposes, you can say it's something which you see in remotes of your TV. Alright, so your TV remotes, or if you have used older versions of mobile phones, then instead of Bluetooth they used to have infrared tool for, or they used to use infrared waves for sharing files. Alright, so infrared wave are electromagnetic waves, but with even higher wavelength than our visible range. Okay, and we cannot see these rays. You cannot see rays traveling from your TV remote towards your TV set. alright, but you know that there are some waves traveling, because of which you are able to change the channel of your TV set. Alright, so if you further keep on increasing the wavelength, you enter microwaves. Alright, microwave are used for radar purposes, and they are also used for heating up your cooking, alright, or your cooked food which you use in kitchen. The microwaves constitute microwaves. Alright, and now after that, the longest form of wave which we come across are the radio waves. Alright, so beyond microwaves you have radio waves, which are again divided as FM radio, AM radio, and also other kinds of radio waves. We don't have to go into their details. Okay, so radio waves are the longest kind of waves, that is, they are the waves which have highest wavelength, and we know that frequency is inversely proportional to wavelength. This means that radio wave have lowest frequency, they have highest wavelength, means they have lowest frequency. Alright, that is, if you move downwards here, you are increasing the wavelength, and if you move upwards, you are increasing the frequency. Okay, so frequency of gamma rays is highest and their wavelength is lowest or least, whereas frequency of radio wave is least and their wavelength is highest. So in visible region, if we see, alright, just look at the colors being shown over here. So visible region start from around 400 nanometer, and which has an approximate color of say violet. Alright, and as you move, okay, as you move on increasing the wavelength up to 700 nanometer, the color changes from violet to red. Okay, and this transition you can remember as VIBGYOR. Okay, that is the 7 colors which we can see, okay, even in rainbows: violet, indigo, blue, green, yellow, orange, and red. Okay, so you have to remember this, and you have to remember that its approximate range starts from 400 nanometer and ends at 700 nanometer. And you have to remember that red belongs to 700 nanometer, that is, red is the color with highest wavelengths. Okay, in visible region it has highest wavelengths and least value of frequency, whereas violet, alright, or this blue region has least wavelength but highest frequency. Okay, so if the wavelengths, alright, for example, if you keep on decreasing the wavelength, alright, so the color starts from dull red and it keeps on increasing or intensifying its red color, and it keeps on shifting towards blue region. And when you have entered blue region, you know that you have entered a region of high frequency and low wavelengths. Okay. So this analysis of electromagnetic spectrum is very important, and you have to remember this order of wavelength, that if you I have been asked in the exam, arrange the rays in their order of increasing wavelength. So you should be able to write that gamma rays have the least wavelength, then X-ray, alright, then UV rays, then visible region, okay, and then infrared, and then microwave, and lastly radio wave. So you have to remember this order, and you also have to remember the VIBGYOR order, and you have to remember that whether red has the highest wavelength or violet has the highest wavelength in visible region. And you also have to remember that visible region approximately lies between 400 and 700 nanometer. Okay, just remember all of this stuff, alright, and try and understand what we have studied here, the analysis of how frequency is inversely proportional to wavelength, and that product of frequency and wavelength is always a constant value, and that value is 3 into 10 to the power 8 meter per second, which is the speed of light in vacuum. Okay, so as you can say, when you say light ray, we don't only mean visible light, but the whole electromagnetic spectrum. Okay, and all these waves, all these different waves, X-ray, gamma ray, UV ray, radio wave, they all have same velocity in vacuum. Okay, so that is why they all travel together. It's not like one reaches first and other reaches later on. Okay, not in vacuum. Alright, in material medium they might have slightly different velocity because of the permeability and other correction factors which you have to use, but we don't have to study those. For us the analysis is quite simple, and there are some aspects which you have to memorize and remember in order to be able to solve numerical questions based on these. Okay, so until next time, and once again thanks for watching Edupedia World videos.